All right, so good evening, everyone. Let's talk about more important practical applications of Spark MLlib. Let me just revise what I've just said. So I will be talking about Spark streaming module and then graphics, but we will look into more hands-on of MLlib module of Spark, and we will implement Spark on Windows and use Spider to do the hands-on. Right? So let me talk about Spark streaming first, and then we will talk about graphics, why it is used, and then we will jump back to the machine learning module. So Spark is known for its speed, right? Whereas if you talk about Hadoop, the map reduce component that it has, it is basically allowing us to do big data processing, but there is high latency. That's the problem. And it is also batch mode execution, batch oriented. That means the data has to come and sit. The data is generating. So the data has to come and sit into HDFS. Once it gets stored, like the sequentially the data is coming in, so we will be generating blocks. In HDFS, blocks will be created. Once the data is stored, afterwards you will be doing the processing. That means you will be collecting map jobs and retrieving the relevant data, right? This map jobs will connect to different nodes and then pull the relevant data. So map jobs will get executed, and then the information that we extract from map will be applied to reduce functions to get the results. But this is offline execution, or we say batch mode execution. Now, if I have to execute data on real time, then we need to have a separate system altogether, because MapReduce is not built for that, right? So what we can do is try and get some third-party application and then try to get the execution done for the real-time data. One of the tool which allows us to capture and manipulate the real-time data is tool called Kafka. There are various other tools that can be used for data ingestion. Scoop is not a data ingestion tool, but it is a data import-export tool. Okay, there's a difference. Real-time data ingestion is what we are talking about here, right? So these are different tools. Flume can be looked at as a data ingestion tool, though Scoop actual job is to just import and export offline data. Flume can extract the real-time data as and how it is generated. Apache Kafka is also another distributed pub/sub system, right? Publish and subscribe messaging system. LinkedIn basically works on this logic, and Kafka was developed by LinkedIn. Later on, it was made out open source. Right? So that's basically about data ingestion tools. But majority of them are only used for streaming the data. But Spark will allow us to process the data also. So generally, in production level, we use Kafka and then Apache Spark for real-time ingestion, data ingestion and processing. I'll say real-time data processing. Kafka is used to make sure that the data is captured as and how it is getting generated in a distributed environment, and then that data will be processed by Spark. Right? Now, Spark has streaming capability. The beauty of Spark streaming is that it creates a container, right? So let's say your data is flowing like this continuously. We put a container, okay? They say this is called as a container. It's like a virtual thing, okay? It's not literally you're taking a bowl and putting there. So this is the data flow, continuous data flow, real time. We put a container for time. We'll decide that, okay, 1 second. Whatever the data comes into this container within this 1 second time, that would be called as an RDD, right? So we are taking the data stream, converting that into RDD. And once the data is converted into RDD, then we will be working with your Spark Core or Spark SQL or Spark MLlib or graphics, right? So this is your data. This gets into blocks like this. Each block is time-bound block, equal intervals, okay? And Spark is called as near real time. Nothing is real time, okay? You cannot do anything at real time, but it is near real time. And Spark allows us to go at 0.5, right? Closeness of to the real time. 0.5 second, half a second. That means the container, the data is getting generated, right? As and how the data gets generated, we create 0.5 second interval bucket or container and convert that data into this dstream RDD, data stream RDD. And now once this is RDD, then we use Spark regular context, Spark context to process this data, right? So this is the simplest logic that Spark streaming uses. It's called as near real-time execution. Okay, and it internally manages the data loss scenario, the integrity of data and all those things will be automatically managed. Okay, see, for example, this is the data that we are getting. This is your master, right? Master basically creates the containers, and here we'll have worker nodes, where worker nodes basically take the RDDs and they start processing it, right? So this is how your architecture looks like. So here we will get broken down RDD blocks, right? We call the data as D streams, data streams. Generally, the IoT devices which are now being used in the industry for generating data and automating industries process, right? Automating the entire industry's process by generating data, right? IR 4.0. So we use these IIoT sensors connected to machines and they generate the data. So we are basically asking the machine on what it is experiencing as. And these data points, which your sensors capture, will be processed for gathering the information, right? So this is a continuous mode of data generation, and we process this continuous data using Spark streaming module, right? So this is the application. Then we have graphics. Graphics allows to manage interconnected networks. For example, social media. We have social media. In social media, there are a lot of people interconnected, right? In this entire social media network, let's say your friend's network, you might want to give value to each person. You are measuring the value of each person, right? If I know the value, then I can also know the influential factor that this personality would have in the network. Each personality would have in the network. This concept is used for marketing purposes. For example, if I have many people interconnected in the social media, right, I would want to understand who is that person who is having most influential value, right? Rather than communicating each and every information, marketing, right? When I'm investing money to market, rather than investing money to market each and every person, I would spend, right, the money intelligently by tapping those people who are influential. So maybe this person is influential. So I would basically hire him or have a contract with him so that he in turn can share the information. Right? I don't have to approach to each of these individual people in the network. When this influential person is communicating something on the social media, automatically a lot of people will reach, right? Basically take the benefit of. So that's network analysis. Here, each person that you are seeing, the dots that I have drawn, they are called as nodes. And in social media, there will be connections will be there, right? These connections are called as edges. Nodes or vertices, right? Connections or edges. Right, so that's basically how we term these network scenario. I mean the network data. This is also used in aviation. It is also used in supply chain, last mile calculation, right? All those things, logistics, for example. These applications, right? Yelp, Zomato in India, then your various other delivery, Amazon, for example. So they need to decide on what is the best route to connect with all these people so that you can deliver the products at much optimized way. I mean, much, right? You need to find out the optimized way so that the fuel is saved at the same time, the customer, the product is reached as quickly as possible. So all that network analysis is performed using graphics module. Okay, so these are basically the two additional modules that we have in Spark. Now let us try and understand how do we implement Spark in Windows system, right? So I'm not going into my Hadoop. I'm not going to my Linux system. I would want to install this Spark in Windows. So I have this small text file created. You might want to start working with this. So we have downloaded the software. If you want, you can again start downloading, or you can just take the downloaded file which is there in your Linux, copy it into Windows, right? And extract them and place it in a specific folder, any folder, wherever you wish, you make sure that you place that in that specific folder. Okay, let me go to the location where my Spark is installed. I think it's installed somewhere here. I need to check, of course, but I'm assuming, yeah, this is where I have my software installed. So this is my Spark 245. I've extracted, I mean, it's pretty old version, but I've already extracted this, right? So I'm using the same version. For you, it would be 247. Same file that you have downloaded. Okay, open this and go to this location, go to this file under conf directory. You'll see this file. So if you open here, you see conf folder. Yeah, this is the second folder, conf. Open that conf folder, and then in that conf folder, you have this log4j properties, right? You edit this file, right click, open it, and edit the file where you see. Okay, let me show you. There will be one location where you will have warning. Yeah, this one. Log level. Yeah, log level, this one. Yeah, so if it is info, if it is set to info here, then the problem is that every small and big message will be published, right? That is the log level basically. you'll not appreciate the Spark working that way. So you will change it to warning. That means only when warning message is there, it will publish. Okay, log level basically. This is to change the way your Spark is going to generate the log values or log data, right? So line number 28, it says log4j.logger.org.apache spark.repl.main. What is REPL, anyone? Yeah, guys, anyone tell me what is REPL? No? Okay. Yes. Very good. So when we talk about programming, we basically talk about REPL, right? REPL basically means read, evaluate, program, and load, or print load, or loop. You can basically call that as read, evaluate, then we say print or program, and then we'll say loop, right? These are basically the interactive shells that we see, right? For Python, for R, for Spark also we have the interactive shells that we are seeing. They are called as REPLs. So in the REPL, what kind of log you want to see? I don't want each and every information. I want only to see warning messages. Okay, that's all. Only one setting. Okay, you update this. Download your Spark software, put it in specific folder, open this conf folder, log4j.properties file, open that and edit log level information from info to warning. By default, it will be warning, but if it is not there, change that to warn. There will be a few template files. If you don't want, you can remove them. Okay. Yeah, I'll share that. I'll share this. Next, this is where we need to do the settings. Now, if I need to work with Spark, remember Spark needs distributed environment, right? It is designed to work on distributed environment. So it needs those libraries, right? So we will not be installing everything. We'll not be installing the library, the software, but we will be basically taking a winutils.exe file, which is mandatory, to Spark folder. And in order to get that, you can use any of these links. Okay, either this or this. So for example, I'll show you. I'll open this. This is a GitHub location where I have my Hadoop software that I'm using is Win Hadoop 2.7. For Spark, we have 2.7. So you can take any of this Hadoop's 2.7 location, go into that, and you see this winutils.exe. Download this. You can simply download this. Right? You can click on download and place this win.exe in a folder where you can define that as your Hadoop home/bin. So you need to define one location, any one location as Hadoop home. Now what I have done is I have used the same location as Hadoop home, also as Spark home. Okay, even in Windows, we need to do that. I'll show you where to do it. Then in bin folder, I have this win.exe file loaded, winutils.exe file loaded. Just copy paste here. If you want to keep this file in a separate section, then you might want to create a folder called Hadoop. Inside that folder Hadoop, you might want to create a bin folder. And then within that bin folder, you have to put this file. So that path is mandatory, right? Now, once this file is downloaded, don't know where I have this file. Okay, it's here. Let me first share this. It will be easy. Let me put it on desktop. There you go. Download it, friends. Right? Use this location to download your winutils.exe, or you can use this folder also. Either this or this. Make sure you download it. Now, let us go to the environment page in Windows. So you need to search for environment settings. You can say edit the system environment variables. I just type EN and I get this result. System environment variables. Search for this. Environment variables. Open, everyone. Now, once you open this, here you will see environment variables. Right? Click on this environment variables under advanced section. And you see user variables, system variables. There are two things. Now, if I want to confine my Spark and Hadoop installation only to the user, then I will be making the changes here at the top. But if I want to make the changes across the system for all the users, then you can edit it in the system variables. Okay. So it's always better to have user variables. It's always better that way. So I would click on new and I will say Hadoop underscore home. Copy, paste here. Variable name and value. Value is this folder. This folder. You just copy paste it. Right? You say Hadoop underscore home. Give the value. Click OK. Similarly, create another new value and now this time say Spark underscore home and give the same location. Right? This way, you are going to set Spark home, right? And you can also set Hadoop home if you want, or you can also ignore that because Hadoop home is not actually required. But if you want to set, you can create Hadoop home. Now, what is important here? What is the other variable that is more important is the path variable, right? You see this path, you double click it. There will be predefined values. Okay, don't remove them. Don't ever dream to remove them. Your system will not work. Okay. Now I need to make sure that winutils location is set in the path. And at the same time, all the binary files I have for Spark. If you would have created two different folders, one is for Spark. If you have winutils.exe file dedicated in another folder, then you need to create this path here, right? You need to give both those locations here. /bin should be there, mind you, right? You can say edit or you can say new and then keep adding that location. Okay, click save. That's it. Click OK and make sure your setting is done. Now, once this is done, your setting is ready. Now you will be opening your command prompt. Okay, my command prompt would be like this in white color because I'm more fond of Linux. So I have changed the settings to white color. I'll say PySpark. You see, my Python 3 is being used and I'm launching Spark. Just like what we have done in your big data Hadoop, right? So this is how you would initialize Spark in Windows, right? Now, if I have to use Spark in Spider, then all you need to do is these settings. And then you have to import PySpark, right? You execute this and you will be able to work with Spider. You can see I'm basically running those commands. Import find spark spark.initialize. Post that, import PySpark, right? You need to import this PySpark. If it is not there already, you need to do that. And you will be able to work with Python in Spider. Shall we try this? Just keep, probably might want to check. Are we doing it? Any errors? Anyone? Yeah, speak to me, guys. Are we doing it?
Sir, question.
Yes, Ashna.
In the step 4 on the text pad that you have shared to us, what is it that we need to remove? Remove template files.
There will be some of the template files here. It will be saying dot template like this, slaves.template,
Remove
right?
all that template.
Even if you have them, that's okay.
It's okay. So it's optional.
Yes.
Okay.
There will be a few template files. You might want to remove that. That's what that point says.
Okay, sir.
Download this winutils.exe, sixth step. And then go to your fifth step. Proceed, let me proceed. So we are going to now work with clustering exercise, right? Let us try and do this clustering. So when I do it on Spider, we will import this find spark and then we initialize that find spark. This would help us import PySpark modules into your Windows Python. Then I'm giving a name to the Spark session that I have imported by creating an application name. I'm calling this application as cluster or clustering. So this is the session. It will have a Spark context enabled. Okay. You can also see Spark session has been established, right? Just like we have seen, I see it will not work here. Just like what we have seen in Linux, right? There will be a local instance enabled for the master. Then it will be taking the bare minimum memory, the standard processors. All those things will internally be initialized. Single node or single thread will be chosen for Spark. So once I have Spark context, then I need to import data, right? And then on that data, I will be performing some tasks. So for PySpark, in PySpark ML, that is ML library, we have clustering. This is module, just like Python modules that we have, right? Scalar modules. So here we have PySpark.ml. And I'm importing k-means library. Import k-means. Then load the data set. This file is in CSV format. So I'm saying read spark.read.csv. Use header is equals to true. Infer schema is equals to true. So you'll automatically create a schema RDD or a data frame. Now, if I want to see the data, then you have to say show schema RDD, right? So it has to use, you need to basically say show command. This is how your data set looks like. We have university name, state, SAT score, top 10, acceptance, student faculty ratio, expenses, and graduation rate. Now, once I have this data, you'll also want to see schema of each field, because we said automatically you need to infer the schema. Spark is reading the data types. And you can see university name is string, state is string, but rest of the fields are chosen as integers, right? So what we need to do, remember, in all the algorithms, ML algorithms, the data that we are working with should be a vector. It does always have to be converted into a vector, right? So we use vector assembler ML features, PySpark ML features. There is a function called vector assembler. We are importing that. Defining the list of features that we are trying to convert into a vector. So here, features list or features column, I'm taking all the 6 columns. This is a Python list. Okay, this is a Python list, line number 26. Now on this list, you are applying vector assembler, which would convert the input into features, right? This is the standard name. Features is the standard name which is given. When I do that, I get feature vector, which basically consists of a single column with all the 6 values. And in those single column, we'll have vectors, 6 values of vectors. So this feature vector is defined, and I'm now passing the data to this feature vector so that it can transform this data into these vectors. So if I say data.show, you can see here, this is the features, which basically is combination of these individual 6 values, right? It is converting everything into a vector, right? So now I'm transforming the universities and selecting same function, feature vector transform university, but select only 2 columns into final data. You don't need full data, we'll only need 2 columns. University name and features. Now, standardization is required on these fields because each value is different, right? So in order to do that standardization, I'm using standard scalar. Standardization, you already know, x minus mu by sigma. So it will do that standardization on the data. So standard scalar, input is your feature, output is z features, standardized values, right? You're saying with standard deviation and with mean. I'm not doing your, I should say that's, there is another standardization scale. I'm not using that. I'm using sigma basically. With standard deviation, I want to do this. We can try and look into the help to understand these various parameters that are there. Yeah, with standard deviation is what we need to convert the standard values. X minus mu by sigma is there, right? So that's what this with standard deviation basically says. So when I do this, I get standardized values. Z features. Now I'm using those standardized values for doing your clustering. So we have defined what needs to be done. I'm passing the data so that it will now convert the data into standardized values. And then this becomes your input data for cluster. Scalar model, transform, final data. So I'll show you here, you will see the final result. Standardized values will give you this reduced scale values. The values will get reduced. Right? So it does transformation of your data into Z levels. The numbers are a little different here, but it is standardizing the data. Next, you would want to try out doing clustering, but what values of K you would try? We don't know, right? So we'll try an experiment with K equal to 3, K equal to 2. So the input features that we want on which the cluster needs to be done, K-means clustering needs to be done, is these Z features. And then K is equals to 3 means I'm going to try and do 3 clusters. Right, I've successfully done 3 clusters. Same way I can also do K means 2, where it does 2 clusters. Then you're passing the input data here, which is the transformed data. Here we are choosing the Z features, right? Z features. So you are basically transforming, or you're basically now trying to do K means. This is for K means 3, this is for K means 2. Similarly, we can do different K values, guys. But let us see what is the value. So if you say compute cost, it is giving us a WSS value within sum of squares. In K-means clustering, if you remember, lesser this WSS, better the clustering. So we are generating, or we are calculating WSS for both 3 clusters and 2 clusters. Yeah. So 2 is 61, 3 is 45.5. Of course, it is reducing, but how much reduction is that? Right? We need to know that. So in order to identify the best K value like this, we will try and do different K values and then choose the K which gives us the least reduction. And in order to decide this K, we have elbow curve, right? So we are just doing the same steps multiple times for different Ks and then see what value of K is drastically reducing this WSS. So I'll create a empty list TWSS. And just like in Python, your regular K-means clustering, here in Spark also, I'm writing the same logic. Choose multiple K values, range from 2 to 9. That means 2 till 8, n minus 1. I'm going to come up with clustering. So K is equals to K. This K is here, chosen from here. You can say I also there. Right? Generate K-means and then fit the data. Compute cost, WSS. These 3 commands is what I'm writing here. And then you are going to print the K value and the sum of squares value. Finally, you are also appending that data into this TWSS. Initially, it is empty. TWSS is empty. Now you can see K equal to 2, K equal to 3, K equal to 4, till 8, it calculates the values. There's this, yeah. It shows the last TWSS value only. Anyways, so this is 2, 3, 4, 5, 6, 7, 8. All these values are recorded in this TWSS. Right? Now, by looking at the numbers, it might not give a better insights. So we will visualize it. So I'm using Matplotlib regular Python plot. matplotlib.pyplot, and then plt.plot. On x-axis, take the values, the k values, and y-axis, you are taking the TWSS value. Plot this, and you see the visualization. Number of clusters and total within sum of squares, and probably I would choose k equal to 4. Looks like this k equal to 4 seems to have drastic decrease. After that, the line is getting a little straighter. You can also try with k equal to 3 as well. 3 or 4 you can try, right? So this is throwing error. Let me remove this and see. Why is this throwing error? Yeah. So this is the visualization that we get. Yeah. So if I have to choose, I would basically go for k equal to 4. From this graph, I'll say k equal to 4 is better, right? So k equal to 4, define that. And do k means with set k as your k, and then your columns, you're selecting the features, and then doing the k-means clustering, or you can just repeat the same commands here, what you are having, right? And the original data we are doing, not z features, but yeah, ultimately this cluster input data we are taking. And when we do the clusters, I get the centers, right? These are the centers. Yeah, 4 clusters, so I have 4 centers, and this is the first center. I have 6 columns, right? For each value, it is giving us the center. SAT score, top 10, right? Acceptance, student faculty ratio, expenses, and graduation rate. So on and so forth. For each cluster, it gives us the results. And here we are printing those centers. Okay, it is basically multiplying it with this exponential value. Only one row, you can see that it is giving us full details, numbers. But this is how all the values would be. You can directly open here and see, or you can print them. Right? Now output, clustered output. We transform this data, select universities and the prediction. Prediction is nothing but the output, the cluster ID. So I'll say cluster output, take the model that you have developed here and use that for transforming the data. Choose university name and the prediction. And if I say collect, dot collect basically gives us the output. I'm saving that output into rows. Right? If I say rows, this is your rows. This is the ID. Brown University belongs to cluster 0, so on and so forth. Now I'm converting this rows into a data frame, Spark data frame. And now you will be able to see the cluster. Okay, yeah, this is the cluster data frame. Right, rows is in, where is that rows? Yeah, rows is in list format, and we have df.print. This is in the Spark data frame format. Right? So you can see it represents each university with the cluster ID. Yes.
Sir, question, because I wasn't able to follow up the earlier. For example, you want to install some library you're using, for example, Spider on Windows, and you want to install some Sparks library. How do you install that one? Because for Anaconda, we use Conda or pip install using the Anaconda. For
Pip
Sparks,
install,
how?
pip install only.
Pip install only, and it will automatically install in that environment? Because
This is
usually there's an environment set up in Anaconda prompt, right? So where it will direct. That's the thing that I'm quite confused.
ultimately we are using Python only.
Okay.
In that Python, we are creating an environment which is Spark environment. It's a framework. It's like a platform. But underneath, everything is Python only. So if you need any package, you have to say pip install only. These are ultimately libraries.
Okay, sir.
Just like other packages.
Understand.
Yeah, everything is there here in this package. PySpark.ml. And if you are able to call PySpark when you're installing PySpark, if you're able to do that, then everything else is there. You just have to import them. Yeah. Try out. See if you're getting any error, then we can investigate.
Okay, sir. I think I cannot follow it right now because I still don't have Java on my laptop, on my Windows laptop. So I need to set up and install and put the path also for the Java. So
It's
I'll
okay.
contact you, sir, if
You're trying it in Linux, right? You don't have to try it in Windows. It's because we are used to Windows, I'm showing it.
oh, okay.
See, do one thing. Do one thing, Ashner. Because you already have your Linux instance and all set up, probably you might want to install Anaconda on Linux.
Okay, sir. I'll just install Anaconda on Linux.
Then use Spider, whatever you're comfortable, either Spider or Jupyter.
Okay, sir.
Code remains same. Right, so I have predicted the result. Now I'm trying to see how many universities fall in each cluster. So 0th cluster, I have 9 universities, 2nd cluster, I have 9, third cluster, 5, and 1 cluster, 2. Right, so this is basically how we see the output. This is not all, it's not printing all, it is only printing 20 by default. You can also say show 25, it will show all the values. Oops, let me rerun that by putting 25. Okay. Yeah, all the 25 universities are shown now. 0, 1, 2, 3. Yeah. Yeah, sure. The Spark code also I'll share. Let me pull this out. These are additional codes. You will not be having them in your LMS. So make sure you're saving it. Yeah, I've sent it. So you might want to just save them out. Yeah, the recorded video is there. So probably you can just go through the recorded video if you want to type the code. Right. All right, so this is about clustering, friends. Now I'll give you a shortcut, okay? I'll show you all the codes that you need readily available. You just have to explore it. So I'll go to spark.apache.org. Come to this website. Here you see documentation. We want older versions. I'm working with 2.4. What is that version? 2.4.7, I guess, right? Two four seven. So I'll click on 247 and programming guide. Once I come to this docs, you can read all this, but I'm not interested in everything. I'm interested in machine learning. Click on this. Yeah, you have MLlib main guide, MLlib RDD based API. If you say RDD based API, it is going to take you to Spark MLlib library, which is now deprecated, right? This is for MLlib RDD based library. The main guide which is now focused on is data frame based library, right? It will clearly say that as of Spark 2.0, RDD based APIs in Spark MLlib package have been entered maintenance mode. That means there is no development, further development in RDD based APIs. It is all this. Okay, now you can click basic statistics. It will redirect you to that. You can do correlation things. You can do hypothesis testing. Scala is the base for your Python because, for your Spark, because Spark is developed in Scala, but you also have Python. Just click on Python and these are your details. See, this is your hypothesis. Chi-square testing is done here. Summarizer is there. So all these, right, codes are readily given for you. These are data sources. So how are you going to load various data sources? If it is image file, how do you load it? Right? So this is given as an example. For R also we have. Spark can work with R as well. Right? Pipelines. These are all various different pipelines we create. You need to understand what does pipeline means in the first place, but this is the code. Yeah. These are all the examples of how the pipeline works. And here you have a code. Right? But yeah, let us go to classification and regression. Classification and regression. These are your prediction models. So classification, you have logistic regression, decision tree classifiers, gradient boost, knife based. In regression, you have linear regression, decision tree regressions, etc. Right? Ensemble techniques. All these are available readily. Then we did clustering. If I click clustering, you go to clustering. Here you have k-means. This is your k-means clustering. You click on Python code and you can see clustering evaluator, clustering k-means. This is what I've used, right? K-means clustering. So we can basically use this particular code for getting our majority of things done. Collaborative filtering. Then we have frequent pattern mining, model selection, hyper tuning parameter, basically hyper parameter tuning. Cross validation is there. Train validation split, right? How do we split and how do we work with each model? So this, if you understand this, on each model, you'll basically be learning on how to apply partitioned data and then training. You also have advanced topics. You might not want to go there. This is a little, right? A little advanced models, optimized base models. You might not want to go there. You might want to stick with classification and regression. Majority of the codes are already available here. Right? So start using these programming guides. As I mentioned, you don't need to go anywhere. All the details are given here. Right? Once you set up, come here, practice on these codes. You'll understand the logic of your Spark clustering code. Right? So that's all about Spark, friends. You have to learn Spark, especially if you're fond of coding. You love writing codes in Spark. If you don't like Spark, if you don't like coding, then probably ML on cloud is what you are going to see. In future, you are going to work with that. Right, so that's all I have with respect to big data, friends. Any questions, anything that you have for me? Do we have any questions, friends, please? Okay. Okay. Ashton, were you able to update your Python to 3?
Yeah, sir. It's successful. So there's a lot of troubleshooting because when you update, some of the folders from Hive will be deleted, and some folders from Sparks is now dependent on Hive, especially for the SQL part. So I need to troubleshoot some of them, and successfully I was able to run it.
Okay, great. But Spark and Hive, sorry, Python and Hive, I don't think there is any relation. Not sure why it is coming up.
Yeah. If for no sir, because in Spark we need to run the we have some activities for SQL, right?
No, you're talking about Spark. I'm talking about Python update.
For Python, no, because if you update the Python, if you update the whole system for PySpark, yesterday we update it, right? We update the whole system actually. Some of them are being deleted.
Okay.
So you need to troubleshoot some of them.
Okay. I'm not sure. Maybe some dependencies got
Some dependencies been
was
deleted.
installed, updated, and all that. But otherwise, these two are two independent softwares. There shouldn't be any dependency.
Okay. But it's just a reminder, sir, if you're going to run if the Spark would run as a SQL or the
Mhm.
you need to have at least, I think the new version to have a dependency with Hive.
Yeah. But Spark you're talking about, is it?
Yes, Spark SQL.
See, Spark SQL comes with Hive. HQL also inbuilt in it.
Oh, okay. So that's why it's looking for that one, I think. Yeah.
Maybe. Because see, the thing is, we have set class path variables and all that in the environment setting. If you see, remember, we did those settings, right?
Yes.
Because of those class path variables which are defined, it is checking for certain libraries in these folders.
Okay, that's why.
That could be the reason. Yeah. All right. So we are done with big data sessions, friends, and yeah. So please practice. Make sure you are learning Spark. See, my sincere advice is you don't have to become a super expert in Spark, friends, but understand the logic of Spark and few of the libraries which are mandatory, because future is Spark. Future is cloud, and on cloud, Spark is the only way to handle big data, right? So even if you don't like it, in future, when you are going to work on big data environments, big data system or big data, and AI, Spark is the way to go. So understand Spark. Rest of the things, that's okay. Theoretical knowledge is good enough, but for Spark, you need to have a little bit of practical exposure. So practice on basic code that I've shared, more than enough. Right, so with that, I'm done. I don't want to waste your time anymore. And yeah, thank you everyone. Ashton, I might want to stand back. I want to talk to you. Yes, Ashton. Yeah, we can talk here itself. Others, we can wind up. Thank you so much, friends. Thanks for joining. Thanks for listening. And please work on the assignments. Don't ignore them. Try and practice them now itself, because you already have Hadoop environment set. Right? All the best. Thank you so much. We'll connect again on in another program. Right? All right. Thank you. Yeah, sorry, I was reading the message. Thank you, guys.